The next example, manufacturing, we'll call it lean manufacturing. And this is about a fictitious company that manufactures two different circuit boards for security systems, and we'll call them blue board and red board. And as I said in a previous video, I've taken this from Pro Model website, and they have set this up using process simulator, Pro Model process simulator. Process simulator uses Visio flowchart system, and it has some limitations. But we're going to set this up in Pro Model itself. So let's first understand what the production process is about. So there are these products or parts, I should say. So these are the parts that are needed to produce these two products, blue board and red board. Okay, now, the blue board requires all of these spring. No, there are some of these parts are used as supplies, kind of, but the assembly stations are, and there are 5 stations for blue: spring, resistor, diodes, LED, and then finally inspection. Now red also has the same set of workstations, except that it does not have LED. I'm sorry, it does not have diodes in its path. So that is your manufacturing side, and then we have the sales side, where we have orders for these two circuit boards that come from our customers to the sales department. And when the orders come in, they enter the order in the system, and then they order the raw materials for them, and then the circuit boards, the packet. Okay, so all of the parts needed for the assembly for blue and all the parts needed for the assembly of red, they come in from our suppliers. They get assembled. And then once the testing is done, once the product is finished, it is matched up with the sales order, and the sales order is then shipped. Okay, so here we have two different processes, the production process and the sales order process. Then there are some interfaces between them, and we're going to make some simplifying assumptions, and then we're going to simulate this process. And the objective is to maximize or to improve our productivity and reduce the cycle time and reduce cost. Okay, so here is the manufacturing process and the sales process. So we have the manufacturing process here, and then the sales order process here. And here is where the sales order process and the manufacturing process meet, and then the product is packed and shipped out. So we're going to assume that over a 30-second period, okay, all the times here are in seconds. Okay, so we get 3 packets of or raw materials or the packages needed for the production of blue. So we get 3 of them every 30 seconds, and for red, the red packets, we get 2 of them every 30 seconds. Now they are accumulated into a batch size. Okay, I think it is 6 and 4. Okay, so they get accumulated and they are sent to these stations. So there is first knitting station, okay, and then springs are added, so those springs, and then the resistors, okay, resistors, Then red will skip the diode. Only blue will go through diode, and then the red goes directly from resistors to LED. Okay. Then once LED is put on, then the product goes to testing, and if the entire batch passes, there are no defectives, then it goes to sort, where the red and the blues are separated out. And if there are defectives, then those batches are sent to rework. They get reworked and corrected. Then the um, reworked batches, okay, they come to sort. Okay, then you have the finished blue boards and finished red boards, and they get matched up with the sales order, and they are sent out. Okay, and the orders are received. There is the the order frequency is given, and we're going to assume that 60% of the orders will be for blue, and 40% are for red. Okay, and both orders are entered and then sent to pick and ship. Okay, so this is the overall outline of the production and sales order process. And here are the information needed, like how long does it take at each step. If for blue, how long does it take? For red, how long does it take? So parts arrive 3 every 30 seconds, 2 every 30 seconds, and the batch size is 6 and 4. For knitting, okay, how much time it takes. And then you have a buffer after knitting in front of springs. So, and there is a move logic, okay, from buffer, spring buffer. Okay, a handler is needed to take those parts to spring. Okay, so then spring gets assembled. Now here it is a common processing time. So both blue and red take the same amount of time, and there is a setup time of 5 seconds at that station. Then from there you go to buffer resistor, and then to move from buffer resistor to resistor, it takes this much time, but you don't need a handler for this. The operator takes care of the movement. Then the resistor is processed. Now here the blue and red have different times, and you have a setup time of 5 seconds. Now from here, blue boards are sent to buffer diode, and then red are sent to buffer LED, because red boards do not need diode. Then you have the buffer for diode. Okay, movement time to diode, again no handler needed. And then diode, this is only for blue. Okay, that takes that much time. And then it joins the buffer for LED. Okay. Now remember, reds are already there because red has skipped the diode. So now at buffer LED, you have both red and blue. They both take the same amount of time. And then, well, I think, okay, so there is no time here. This is not right. That's where the time is. Okay. So from buffer LED, there is a move time. Okay, no handler needed. Goes to LED, and then at LED, both red and blue take the same amount of time. It goes to test, buffer test. From buffer moves to test station, and you need a handler for that. Okay, normal 10,2. They're all in seconds. And then the test time is same for both blue and red, and there is a 5 second setup time. Now buffer, okay, after testing, okay, so you're going to have some batches going straight to sort, some going to rework, and the number of defectives is going to follow binomial distribution with probability of 0.2 that a part will need rework. And the n is going to be based on the batch size. So blue batch size is 6, red batch size is 4. Now routing is to rework only if there are defectives. Otherwise, it will go to sort. Okay, so at rework needs 15 seconds per unit to rework, both red and blue, and 5-second setup time. And then it's going to join buffer sort. Okay, buffer sort to sort station, you need a handler, and normal 8-2 is the time needed to move. Then there is no time involved in sorting, and sorts into buffer blue, buffer and red. Blue finished and red finished, I guess I should say buffers. Blue or red finished. Okay. And then the order process, you get orders randomly 6 per minute. Okay, 60% are blue orders for blue boards, 40% for red boards. Okay, sales entry takes that much amount of time, and packing and ship. And here is where you're going to match up the order with the parts, finished parts. Yeah, and then it goes out. All right. So this is the process that we want to first set up, and then we can define variables for collecting more operational statistics than what Pro Model generates by default. So let's first look at setting up the process in the next video.